We're going to go ahead and start talking about Coulombs Law, the next section. And I know some of you had some questions looking over this, but what we're going to do is we're going to start answering some of those questions. Some of the things that we're going to do is we're going to look at and identify the relationship that exists between force and charges, and force and also distance. We're going to calculate the electric force on a charge using Coulombs Law. And then the last thing what we're going to do is we're going to look at multiple charges, and we're going to use vectors, calculate a resultant force that's going to be acting on a single charge because of two or more charges. What happens when two of the same charges are brought together? Well, we found out that those charges were going to end up repelling one another. What happens when we have opposite charges or a charge and a neutral object? Well, we're going to find out that, of course, those are going to attract one another. But how large is that force of attraction, or how large is that force of repulsion acting on those objects? Well, that was going to be proposed by Charles Coulomb. Charles Coulomb wanted to know the relationship that existed between charges and force. Okay, so it dealt with those charges and it dealt with the distance that actually was between them. So what happens to the attraction or repulsion when distance is reduced? Well, think about it. Let's use magnetics, something that you can kind of visualize. When you bring magnets closer together, they become stronger, meaning that they want to attract or repel one another more the closer they are together. Charges, on the other hand, those are going to be things that are going to be directly related. That when we increase the charge, you're going to find out that that charge is going to be increased, or that force of attraction is going to be increased between them. Charles Coulomb found that force varied with 1 over the distance squared. Now notice, we're talking about the force, but look at what's going on with the distance. We are actually squaring that distance, but it is an inverse. Okay, so force and distance were inversely related with that distance squared. Meaning that if distance got 3 times greater, meaning we go from here to 3 times bigger, well, let's go ahead and look at that. 3 times bigger, first of all, the reciprocal is 3 times less, but it is squared. So 3 squared 9 means that the force went down 9 times. Let's go ahead and look at now all of a sudden, let's bring it 5 times closer. Okay, so distance went down 5. Well, obviously the reciprocal of down 5 means up 5, but now we go ahead and square that, so we're going to find out that the force ends up getting 25 times bigger. He also found that force varied directly with charge, meaning that if charge goes up, force is going to be going up also. Okay, so force and charge were directly related to one another. Well, what he did is he went ahead and he said, let's go ahead and throw everything together into one equation. He found that the force was going to be equal to some constant K multiplied by charge 1, multiplied by charge 2, and then what he did is he divided it by the distance squared. K is a constant, okay? That constant being 9.0 times 10 to the 9th Newton meters squared Coulomb squared, meaning that Q has to be in coulombs, distance has to be in meters, and what that'll do is that'll leave force being measured in newtons. So if we look at an example problem, it says that we have an electron and a proton of a hydrogen atom are separated on average by a distance of about 5.3 times 10 to the negative 11th meters. Find the electrical force that each particle exerts on the other. Well, first of all, let's go ahead and think about this. Proton and an electron. Well, one's positive, one's negative, so obviously that's going to mean that we have attraction that's going to end up occurring. You might ask yourself, well, what is the charge? Well, if you think back to what we talked about last section, we had that charge of that electron being 1.6 times 10 to the negative 19th. So if we go ahead and look here, F equals K, Q1, Q2, divided by distance squared. If we plug those numbers in, 9 times 10 to the 9th, that is that constant, multiplied by the charge of the electron, that's the negative 1.6 times 10 to the negative 19th, multiplied by the charge of the proton. That one's a positive, 1.6 times 10 to the negative 19th. We're going to divide it by that distance squared that was given up in the example problem, 5.3 times 10 to the negative 11th. What you'll do is you'll square that distance first, and then you'll multiply those top numbers divided by that distance squared, and you're going to find out that your answer is negative 8.2 times 10 to the negative 8th newtons. All that negative symbol means is force of attraction. If we had two protons, okay, so instead of the negative 1.6 times 10 to the negative 19th, we would have had another positive 1.6 there. We would have got the same value, 8.2, but it would have been a positive value, meaning that that is force of repulsion. So if you see a negative, that means it's attracting. If you see a positive, that means it is repelling.